A non-fused disconnect switch can be used for a residential air conditioning compressor only if the compressor has built-in overcurrent protection. This protection can be in the form of a thermal overload relay or a high-pressure switch. A combination no-fuse disconnect and ground fault interrupter is a convenient device that can be used for residential air conditioning compressors. However, it is important to note that the ground fault interrupter is not a substitute for overcurrent protection. The ground fault interrupter is designed to protect against electrical shock hazards, not overcurrents. If the compressor nameplate states that it requires a maximum fuse or breaker, then a fuse disconnect switch must be used. The fuse or breaker size should be in accordance with the nameplate rating. The panel breaker may be sufficient to provide overcurrent protection for the compressor, provided that the breaker is sized appropriately for the compressor's nameplate rating. However, it is important to check the manufacturer's instructions for the specific compressor to verify that the panel breaker is an acceptable form of overcurrent protection. In summary, a non-fused disconnect switch can be used for a residential air conditioning compressor only if the compressor has built-in overcurrent protection. If the compressor nameplate requires a maximum fuse or breaker, then a fuse disconnect switch must be used. The panel breaker may be sufficient to provide overcurrent protection, but it is important to check the manufacturer's instructions to verify. Now let's delve deeper into the considerations for using non-fused disconnects with residential air conditioning compressors. Overcurrent protection is a critical safety measure in electrical systems. It's designed to prevent damage to equipment and wiring caused by excessive current flow, which can result from short circuits, ground faults, or overloads. The National Electrical Code, often referred to as the NEC, provides comprehensive guidelines for electrical installations, including requirements for overcurrent protection. When dealing with air conditioning compressors, understanding the NEC requirements is paramount. A non-fused disconnect, as the name suggests, lacks built-in fuses. This means it relies on an external overcurrent protective device, such as a circuit breaker in the electrical panel, to interrupt the current in the event of an overcurrent condition. Conversely, a fused disconnect incorporates fuses directly within the disconnect switch. These fuses are sized to protect the specific equipment connected to the disconnect. The NEC permits the use of non-fused disconnects in certain situations, provided that the equipment being served has its own integral overcurrent protection. In the case of air conditioning compressors, some units are manufactured with internal overcurrent protection devices, such as thermal overload relays or high-pressure switches. Thermal overload relays are designed to sense excessive heat buildup within the compressor motor. When the motor temperature exceeds a predetermined threshold, the relay trips, interrupting the power supply to the compressor and preventing damage. High-pressure switches, on the other hand, monitor the refrigerant pressure within the air conditioning system. If the pressure rises above a safe level, the switch opens, shutting down the compressor. These internal protection devices serve as the primary overcurrent protection for the compressor, allowing the use of a non-fused disconnect. However, it's crucial to verify that the compressor indeed has this built-in protection. The manufacturer's specifications and product documentation will clearly indicate whether the compressor is equipped with a thermal overload relay, a high-pressure switch, or another form of internal overcurrent protection. If the compressor lacks this internal protection, a fused disconnect must be used. The fuses in the disconnect provide the necessary overcurrent protection, ensuring that the compressor is adequately protected against faults and overloads. When selecting a fused disconnect, it's essential to choose fuses with the correct ampere rating. The fuse ampere rating should be based on the compressor's nameplate information, which specifies the maximum fuse or circuit breaker size allowed for the compressor. Using fuses with a higher ampere rating than specified can compromise the overcurrent protection and potentially damage the compressor. The combination of fuse disconnect and ground fault interrupter offers additional safety benefits. A ground fault interrupter is a device that detects ground faults, which occur when electricity unintentionally flows to ground. Ground faults can pose a serious shock hazard, as they can energize conductive surfaces and create a path for electricity to flow through a person's body. The ground fault interrupter is designed to quickly interrupt the circuit in the event of a ground fault, reducing the risk of electrical shock. While a ground fault interrupter provides protection against electrical shock, it does not provide overcurrent protection. Therefore, it cannot be used as a substitute for fuses or circuit breakers. The ground fault interrupter is an additional layer of protection that complements overcurrent protection. The panel breaker, also known as a circuit breaker, is the main overcurrent protective device in the electrical panel. It's designed to protect the entire circuit, including the wiring and the equipment connected to the circuit. In some cases, the panel breaker may be sufficient to provide overcurrent protection for the air conditioning compressor. However, it's important to ensure that the breaker is properly sized for the compressor. The breaker ampere rating should be based on the compressor's nameplate information, taking into account the compressor's full load amps and other relevant factors. Additionally, it's crucial to check the manufacturer's instructions for the specific compressor to verify that the panel breaker is an acceptable form of overcurrent protection. Some manufacturers may require the use of a fuse disconnect, even if the panel breaker is adequately sized. This requirement is often based on specific design considerations or safety standards. In summary, the decision of whether to use a non-fused or fused disconnect for a residential air conditioning compressor depends on several factors, including the presence of built-in overcurrent protection in a compressor, the compressor's nameplate requirements, and the manufacturer's instructions. If the compressor has internal overcurrent protection, a non-fused disconnect can be used. If the compressor requires a maximum fuse or breaker, a fused disconnect must be used. The panel breaker may be sufficient, but it's essential to verify with the manufacturer's instructions. Always prioritize safety and follow the NEC guidelines when working with electrical systems. Remember, proper overcurrent protection is crucial for preventing damage to equipment and ensuring the safety of people and property. Furthermore, it is important to elaborate on the process of determining the correct fuse or breaker size for an air conditioning compressor, as this is a critical step in ensuring proper overcurrent protection. The compressor's nameplate is the primary source of information for determining the appropriate fuse or breaker size. The nameplate typically includes the following information: the compressor's rated voltage, which is the voltage at which the compressor is designed to operate; the compressor's full load amps, which is the amount of current the compressor draws when operating at its rated voltage and load; the compressor's locked rotor amps, which is the amount of current the compressor draws when it is initially starting up; and the maximum fuse or circuit breaker size, which is the maximum ampere rating of the fuse or circuit breaker that can be used to protect the compressor. To determine the correct fuse or breaker size, you should first consult the compressor's nameplate to find the maximum fuse or circuit breaker size. If the nameplate only provides the full load amps and locked rotor amps, you can use the following guidelines to calculate the appropriate fuse or breaker size. For fuses, the fuse ampere rating should be at least 125% of the compressor's full load amps. This allows for the normal starting current of the compressor without causing the fuse to blow. For circuit breakers, the breaker ampere rating should be at least 150% of the compressor's full load amps. This provides additional protection against nuisance tripping due to the compressor's starting current. In addition to the full load amps and locked rotor amps, you should also consider the compressor's service factor when determining the fuse or breaker size. The service factor is a measure of the compressor's ability to handle occasional overloads. Compressors with a higher service factor can typically tolerate higher overloads without being damaged. If the compressor has a service factor of 1.15 or higher, you can increase the fuse or breaker size by 15%. However, it is important to never exceed the maximum fuse or circuit breaker size specified on the compressor's nameplate. Once you have determined the appropriate fuse or breaker size, you should select a fuse or circuit breaker that is specifically designed for use with air conditioning compressors. These fuses and circuit breakers are typically time delay fuses or inverse time circuit breakers, which are designed to withstand the high starting currents of compressors without tripping unnecessarily. It is also important to ensure that the fuse or circuit breaker is properly installed and connected. The fuse or circuit breaker should be installed in a disconnect switch that is located within sight of the compressor. This allows you to easily disconnect the power to the compressor for maintenance or repair purposes. The connections to the fuse or circuit breaker should be tight and secure to prevent overheating and potential fire hazards. Finally, it is important to periodically inspect the fuse or circuit breaker to ensure that it is in good condition. Fuses should be replaced if they are blown or damaged. Circuit breakers should be tested periodically to ensure that they are tripping properly. By following these guidelines, you can ensure that your air conditioning compressor is properly protected against overcurrents and that your electrical system is safe and reliable. Let's further discuss the importance of ground fault circuit interrupters, also known as ground fault interrupters, in residential air conditioning systems. As previously mentioned, a ground fault interrupter is a device that detects ground faults, which occur when electricity unintentionally flows to ground. Ground faults can happen when there's a break in the insulation of a wire or component, allowing electricity to come into contact with a grounded surface, such as a metal enclosure or a water pipe. These faults pose a significant risk of electrical shock, as they can create a path for electricity to flow through a person's body if they come into contact with the grounded surface. Ground fault interrupters are designed to quickly interrupt the circuit in the event of a ground fault, typically within a fraction of a second. This rapid interruption significantly reduces the risk of electrical shock, potentially saving lives. The NEC requires ground fault interrupter protection in certain areas of the home where there is a higher risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. While ground fault interrupter protection is not always required for air conditioning compressors, it is highly recommended, especially in outdoor installations or in areas where there is a potential for moisture exposure. Installing a ground fault interrupter for your air conditioning compressor can provide an extra layer of safety, protecting you and your family from electrical shock hazards. When selecting a ground fault interrupter for your air conditioning compressor, it is important to choose a ground fault interrupter that is specifically designed for use with air conditioning equipment. These ground fault interrupters are typically rated for higher amperage levels and are designed to withstand the demanding conditions of air conditioning applications. It is also important to ensure that the ground fault interrupter is properly installed and connected. The ground fault interrupter should be installed in a readily accessible location, such as near the disconnect switch for the compressor. The wiring connections should be tight and secure to prevent loose connections and potential electrical hazards. Regularly testing the ground fault interrupter is crucial to ensure that it is functioning properly. Ground fault interrupters have a test button that allows you to simulate a ground fault and verify that the device is tripping correctly. The ground fault interrupter should be tested at least once a month or more frequently if there is a concern about its performance. If the ground fault interrupter fails to trip when the test button is pressed, it should be replaced immediately. In addition to ground fault interrupters, there are other safety devices that can be used to enhance the safety of your air conditioning system. Surge protectors can protect your compressor from voltage spikes and surges, which can damage sensitive electronic components. Lightning arresters can provide protection against lightning strikes, which can cause severe damage to electrical equipment. Regular maintenance and inspections are also essential for ensuring the safety and reliability of your air conditioning system. A qualified electrician can inspect your system for potential hazards, such as damaged wiring, loose connections, and corroded component. They can also perform routine maintenance tasks, such as cleaning the coils and checking the refrigerant levels to keep your system operating efficiently and safely. By taking these precautions, you can ensure that your air conditioning system is safe, reliable, and energy efficient. Remember, safety should always be your top priority when working with electrical equipment. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician.